In this video, I will tell you how you can make a target lock-on system for your game. For demo purposes, we will be focusing on a 3D third-person game today. However, the concept is pretty much the same across all genres in all games, be it a third-person, a first-person, or even a 2D game. So stick around and enjoy the video. Now, let's start. Okay, so for our initial setup, we just have a basic 3D scene setup here, consisting of two enemy nodes, which are just empty character body 3D nodes, and our player node, which again is just your boilerplate character body 3D with a camera attached as its child. Now, instead of just writing the code and saying goodbye, I would like to take some time to explain to you the logic behind target locking and as well as of the code that we will be writing, as only then this concept will become scalable for both you and your game, and not just something you copy and paste off of internet. Okay, enough yapping. The concept is actually pretty simple. Let's say there are two enemies in front of you, denoted by these two red devils, both of which lie within your targetable area. Now, the question is, what is a targetable area? Typically, in your games, you are only allowed to lock on to your target which is present at a set distance away from you. I mean, it's not like you can lock on to your enemy which is present at the very far end of the level. That does not make too much of a sense, right? So, this distance, or rather this area surrounding you, is called your targetable area, which is typically represented by a conical shape like this. So basically, any enemy within this area has the potential to become lockable by you. Now, the question arises, how do we calculate exactly which enemy we lock onto? Now, there are actually a lot of ways on how you can go about this. However, the most common method used by typically all games is just basically picking the nearest enemy to you. Of course, there are some other methods as well, adding some angular calculations, etc. and whatnot, but the distance method is typically the most common one. So based on that, our lock-on target would be this middle enemy right here. Now, what happens once you lock on to an enemy? So essentially, your camera now rotates towards it. In a more technical term, your camera will from now on be looking at that particular enemy's position till the time you turn off your target locking. Speaking of that, there are a few scenarios based on which we turn off our target locking. The first is pretty obvious, that is, you turn it off by the press of a button, typically the one you use to turn this locking mechanism on anyways. The second case is when your enemy itself dies or unloads itself from the level. And the third case is when your enemy actually runs away from your targetable area. That is, it is far enough that you cannot actually lock on to it anymore. And once you get out of this lock-in state, your camera movement is now again free, and should hopefully now start working again as it was before all of these shenanigans. Okay, that should be enough for the core logic. And now let us start on implementing the same. Let us make a new function called lock handler that will handle, hence the name, our lock and target selection logic. However, before we begin implementing this function, we need to set up our game scene a little bit. So for now, let us just make this an empty function and move back onto our game scene. Once here, we will firstly make our targetable area. To reiterate, this will be the area within which we are able to lock onto our targets. Let us just make this a child of our player. And speaking of targets, now how do we tell target area which enemy does it have to look for or scan for? There are a couple of ways to go about this, but what I like to do is to actually make a group called enemy and add our enemy nodes to that particular group. Now what will we do later on in the code is to tell the targetable area to scan and register only the nodes belonging to this particular group. This is just a quick way of filtering out from a required target to a non-required target. Of course, without required targets being nodes belonging to the enemy group. Now back to the code, we will be making 4 variables. One is just a reference to our target area. The second is a list of all the potential candidates for our targets. The third is the reference of the target we have actually locked on to. And fourth is just a boolean to check whether we are in a locked state or not. Now our lock handler will only fire once we have pressed our lock on input key, which in my case I will point to middle mouse button later on. Now within this condition we have two more scenarios. The first being that we are already in a locked state. In this scenario, we actually want to come out of our locked on state. The logic for this will be handled by our clear lock function, which I will define later on. The second scenario being we actually want to lock onto a new target. So in it, we first select our new target and then check our is locked on state to true, provided we were able to find a new lock on target. Now let us define the logic behind selecting the target. Again, as said before, I will only pick the nearest target that is available to me out of all of the potential candidates. So the logic is pretty simple, that we loop across our entire candidates array and just find the one nearest to us. And once they come out of this loop, we just return whatever target we have acquired. This value can also be null if there were no targets available. In that case, our is locked boolean will be false. Now to actually fill out our candidates array, we have to define our targetable areas is body entered and is body exit signals. So just connect two new functions to those particular signals, and inside the on body entered, we will append to our candidates array if the entering body belongs to the enemy group, and just a reverse on the exiting side. We will also have to call our clear lock function provided that the exiting body is our actual current target. Now the clear lock function is very simple. That is, in it we just reset our is locked boolean and our locked target variable. That is by turning them false and null respectively. Now let us demo out our code till now. Also, for demo purposes, what I will do is that I will instantiate a sphere around our lockdown target just to show you guys that our code till now is working. So as you can see, our code is working and we are able to lock on to a particular target. However, our camera is still not rotating towards it. And the reason is because we have not coded that part in yet. So let us just work on that now. Similar to before, our rotation logic will be handled by the rotation handler function. And this function will only fire when we are in our locked state. If we are, we will just have our camera look at our target's global position. If we demo this out, we will see that everything looks pretty good. However, and this is optional, only our camera is rotating towards the target, but both our body and the target area are not. In context of this demo, both our player and the target area are pointing straight ahead towards that wall, but not towards the enemy, or in a more technical term, towards the forward direction pointed by the camera. To fix this, we just have to do a little bit of vector math. That is, we will get our direction vector pointing from the player towards the enemy minus the y-axis and get the angle of this vector, and then rotate our player every frame bit by bit using slurp. And now I think we have got a pretty solid lock-on mechanism. As you can see, now both our camera and the target area are looking at towards the enemy. And with this, we are done for today. Hope you guys liked the video. Don't forget to like and subscribe and comment to boost the algorithm. Okay, bye.